So, good morning, everybody. Welcome to Plastics Europe. Welcome to the first presentation of the day. I'm the host of the whole day here on stage, and at first I want to give a short inside view, short puff horse riding through the topic of circular economy and what Fraunhofer and the cluster of circular plastics economy is doing in this topic. So is there one answer to the pressing question for the future? This is something that I see a lot of time also when I speak to politicians, that the idea is there something with the circular economy where when I'm thinking a lot and I think very deeply and I bring together experts from different branches, that there is something like a question. And I strongly see, no, there is no answer because it is a very complex question to answer. So you see here, as a cluster of circular plastics economy, 6 institutes of Fraunhofer are working strongly together to answer this question, and we are even picking up the other institutes when we have got technological questions to answer. We always stand together with, or we always start with companies to speak about their business model, because in core is what is the value proposition of the company, and how can we really go to value. What are the key trends, market forces, macroeconomic and industry forces, to be straight on the business model of the company and to find technological solutions, because when it economically does not work, it is even hard to realize, or it is not possible to realize a circular economy. Here you see, this is not a circular, this is a linear way how we produce. And you see here from the oil to the recycling, there's even no connect between end of life and the raw material, and this is definitely one of the big challenges. So if we need the R strategies, remanufacturing, recovering, reuse, recycling, and so on, the different business models have to come together, and this is one thing that is very important also when we go to Brussels or when we go outside of Europe to discuss how this can be realized. So the circular economy, is it a new principle? No, a lot of things are not a new principle. As I've brought these 2 slides with me, Caterpillar, for example, they started in 1973 to have remanufactured parts, as you see on the right side. So remanufacturing, repair, refurbishment, these are strategies that are used since decades. We see here, this is not something like a packaging or a packaging foil. This is a high quality product. But you see here over 7,000 parts are realized in this R strategy remanufacturing. 90% of all parts are returned to Caterpillar, and this is something that brings a lot of positive dynamic also inside the business model. High quality standards, spare parts for decades. So this is one of a lot of examples that already exist. The topic of product service systems, as you can see here. So we took a children's car seat to see what are the possibilities, what is the status quo. We took this together with the other 5 institutes, and we have seen when we take this child car seat, we have got 100 components, 15 different materials. So there are metal components, but 14 different polymers that are used to have this high quality standard seat, and 13 kilograms. So to be closer to a circular solution, we have to work on the product, because one thing is sure, 80% of the environmental costs are related to the design of the product. So we really have to focus on the product and how the product is built up, because otherwise we have got a lot of problems regarding the product use and even the recycling afterwards. And chemical and mechanical recycling is a big topic of today. As more complex the product, as higher the need for also very complex chemical recycling technologies. So we try to see what is the resource that we have to use. So that you see the status quo is here. The polymer industry, and this is very nice to see, is growing very intensively over the next decades. And when we want to defossilize, we have got 3 possibilities. On the one hand side, recycling, so keeping carbon in the loop. On the other hand side, we have got the bio-based, so bio-based polymers. And the third row will be the carbon taken of carbon capture and utilization. But this technology is even rising very fastly now, but it takes decades to really transport the masses inside the polymer system that we really already need. So we said, okay, at first we have to change the design. It should be an easy design. It should be easy for repair, remanufacturing, and reuse of this product, as you can see here on the right side. The next challenge, we said, okay, when we've got 3 possibilities to source carbon, we take the biomass as a source. So PLA was used for this child car seat I will show to you. And as you can see here, we have got different materials. We have got a foam, we have got a very stiff layer, we have got a surface material, and this is all made of 100% of PLA. We could even use other fossil-based polymers, but we said, okay, we take the challenge and go inside the bio-based. And we used a lot of different technologies, so this is what Fraunhofer stands for. So when you as a company come to us, we want to scale up as fast as possible. We want to go to higher TRLs together with you as fast as possible. And here you see when you've got a new child car seat, 100% made of the same material, we even think in these new business models. So you see here on the right side, you've got the product manufacturer, and usually he is not coming into the game one more time. But when we've got a multiple use, so the owner of this product is still keeping the ownership, then it is possible to really have loops and to have a good remanufacturing, refurbishment, and so on. This all counts for high value quality products. When we have got a material for packaging, it is even much harder or even not possible to have something like this new logics inside. What do we also need? Because otherwise, even the chemical recycling is hard to handle when you're going to the LCA topic. We have to use the renewable resources. This is one of the very elementary topics. Even when you use gasification, you have the energy to come down to the molecule again, and on the other hand side, to build up the molecule again to a high value polymer. So we have to see that renewables are coming inside the system and for using all of these different topics. So today we are focusing on recycling, and the recycling is really for us always a hand in hand of mechanical and chemical recycling. But today, because you are experts, but in a lot of times I do not speak to experts, so I have to use easy pictures. And easy pictures are, everybody knows, even a lot of people who work in Berlin, who work in Brussels and in other cities where politics are done, everybody knows these garbage cans, and that there is a great mixture of different polymers. So I transfer this to a room. So a room that is very messy. It is relatively easy to clean up the room when you've got a digital product passport and a digital material passport, because you exactly know where to put the products inside. So it's relatively easy to clean up the room. But we all know it, when you're opening one door, perhaps behind this, it is even messy again. And to show this, I show Lego here shown, and it is relatively easy to say, okay, we cleaned up because we put all Lego inside. So in our branch, we put all polymers, but PA is together with PP, we have multi-layer materials. So when we put them together, we have just polymers, but it's even hard to handle. So we have to sort them on the one hand side, and on the other hand side, we have to have the right technologies. So what we have to do to really clean up this room is, we also have to go inside our furniture and really see that we collect this. So this is a picture for chemical recycling that I show in a lot of times, because I see people who are not related to polymers, they do not even have an idea of a polymer chain, of mechanical recycling, additives inside the polymer and so on. And so you have to, always have to take pictures like this. I think this makes it easier to discuss this. So to come to one conclusion of the short introduction of the recycling technologies. We will also hear something about this later very intensively. For me, one thing is absolutely clear: material, mechanical and chemical recycling are working hand in hand, so we need both. We have got the different kinds: solvent-based, solvolysis, pyrolysis, gasification, so we have to see that we use and scale up these technologies, because without the scaling, we do not have even a chance to really demonstrate. So we have to come to tons, to really tonnage to do this. Companies are moving, companies are investing in this. In Europe, it is also a lot discussion about legislation, because when you invest a lot, on the one hand side, you have to have a positive outcome. And when you are in directly competition with virgin materials, we all know it is very hard to implement new technologies inside this. So this is one of the big challenges we definitely have. Coming back to the Fraunhofer perspective, what we are building up, and this is one equipment that we have inside Fraunhofer, that to really get an idea of the scale we are thinking of and what we are also working in. You see here the pyrolysis coming here. It is not so easy as I thought. So, you see here on the right side, this is the pyrolysis. So 1/2 ton of biomass we can put inside this equipment. Then we have got the whole line. We come to the biochar, we come to the bio-oil, we also come to hydrogen that is stored. And in the front, we can, on the one hand side, produce biodiesel, so also a sustainable aviation fuel. On the other hand side, we can also take this carbon and to go to the polymer route. So when we speak about projects, this is always the scale where we want to reach as fast as possible. So coming to a short conclusion, because 40 seconds are left. Which lever is rarely discussed? And this is one thing that is, I think, a very important topic when we speak about a circular economy. The topic of consumption. So we all like and we all love products. And we live in a world where buying more products is a positive thing, and people are kept to buy products. So two pair of shoes per year is better than one, 4 is better than 2, and this cycle. So we can be as efficient as possible. But when the demand is growing so fastly, it is even very, very hard to keep this. So for me, it is about high quality products, because I wanna wear t-shirts. I do not want to lose t-shirts or shoes and so on. But the thing is, how can we do it in a more positive way and to reduce this enormous amount? Related to furniture, we see here, I really like IKEA on the one hand side. Vogtlauer is one high quality company, and these furniture last for very long time. So slowing the loop is always related also to material use and how long we keep the products in the cycle. So thank you very, very much for your attention. Please stay here. It will be a very intensive day, also on mechanical and chemical recycling in focus. Now we will hear something from Professor Uwe Clausen. He is coming also from Fraunhofer. He is a specialist in logistics. His whole institute is related to logistics very much. You know, logistics is one also of the important points, because logistic, reverse logistic, all our products have to be handled, and the waste also. So welcome on stage, Uwe Clausen. The stage is yours.